finish your studies at the Faculty of Mechanical Engineering here in Maribor. And today we gathered to listen to the presentation of Ehsan Hashem, who is a student of the second degree mechatronic studies, which would be magister studies in our faculty, and he finished all the required exams, all tasks that were connected to the studies. He finished well, and he is now eligible to present his final work, which is called Automatizacja in robotyzacja proizvodne linije in sestavljanje trofaznih pametnih električnih števcev. I have it written in Slovene here, so I will forget. This is the final presentation we had today at 13 and 20 in this room. And the commission carefully studied your final work and found that it is written according to the requirements, and you can now present your work in front of the commission. After your presentation, which will take around 10 minutes, we will have a brief question and answers session, and after that we will ask you and the public to leave the room for a few minutes so that we can discuss your presentation and find final conclusion. Yes, and after that we will call you back and we can announce the results. With this, I will leave you to the presentation and you can start.
Okay, so thank you for coming and hearing this opportunity, and I would like to show you my presentation regarding the automation and robotization of a manual workstation of a three-phase smart meter that it is produced in Iskra Imco. So let's dive into the content. So Iskra Imco thinks about automation and robotization when there is the pandemic started in 2020 or 2019. So they, because of the lack of people there and the high demand of producing the three-phase smart meter, this is a high-run meter assembly line. That's why they think about automation. So in this master thesis, we will do our aim to automate a manual workstation in the beginning of this line that produce two types of meter: the CDMA, this is produced for Netherlands market, and the generic meter, which is generally for European countries and African countries and Asian countries as well. And the robot cell will be capable of assembling these two types of meter. The design was done using SolidWorks for all the components that we have. The robot studio used to simulate the production, the whole production automated, and we're using also TIA Portal for the PLC, HMI. Now currently this line is 42% automated. Then it will be, after we implement this automation, it will be 71% with just 2 workers at the end of the line. So this line is called AM550 for producing the three-phase smart meter. So this line is basically 2 workers working in front of the line, as we see here. This is the 2 workers, and they're producing around 500, they said, but exactly 475 meters per shift for the generic meter and 317 meters per shift for the CDMA. So I made like a list of tasks that it's done for each meter. So this is for the generic meter. each task, how long does it take, and then the total of the generic is 61 seconds. For the CDMA, it's 91 seconds. It's a little bit longer. This is because how it is assembled, it's a little bit harder. Maybe show this in the another slide. So first here we can show how she's doing the manual work. So she's just putting it inside the ionizer and then putting the sticker for the barcode, and then she puts the generic clamps, because there's two different of clamps, the generic clamps and the CDMA clamps. So this is just an example to show how it is done in the manual workstation. So she puts the two in the same time, and then she puts after that the PCBA. So I will just run this a little bit because of the time. Video for this, just that she puts after that the PCBA inside the generic clamps, and then she scans basically the whole meter. Okay? Because there is another videos. So basically here we show the PCBA. So the terminals, the copper terminals in the CDMA are different from the generic, which is easier, of course, to put the clamps inside. So here there is no room that we can put all the clamps together. So if we saw here the next slide, so first she puts the clamps, this is the metal clamps, and then she puts the PCBA inside, inclined in that way, and then it goes inside the holes of the base. Okay. Then we have the assembly for the CDMA is different, that she inclined the clamps, as you see here, the clamps are inclined, and then inserted one by one. And at the end, the meter is assembled all inside vertically. So there is the challenges that faces our automation here, that we need to create a tool that is capable of doing both clamps insertion, whether it's inside the plastic base or it is inside the PCBA. So we need to create these two tools that is capable of gripping the metal clamps and put it inside. And also the design of that we should create for the tool that grips the plastic base for both meters, and also gripping the PCBA for both types of meter. And also there's a part that is called the L-shaped plastic part that we need to also grip and place inside the PCBA. Also the designing of all the components that for the feeders, customized feeders that deliver to the robot, the different parts, metal clamps, the L-shaped plastic part, and also delivering the both PCBA and plastic base for the so basically, after this a lot of research with Iskra Inc. colleagues, we found out that we could possibly create one robot that is 6 axis, and that can basically have the pneumatic cylinders on the pneumatic drawers on the side. So it's just delivering the plastic base and the PCBAs to the robot. So, and also in the same time we have the ionizer on the pneumatic drawers. So we don't have time, we don't use this time the robot putting the plastic base in the ionizer. And also the wash firmware is in front of it, and the scanner is also on the firmware. The feeders will be in front of the robot, and it will bring the clamps, the metal clamps for the generic and the CDMA, because there is 2 different clamps, and also the L shape will be delivered for the So what we have done here, that after we saw that it is possibly that we can use the pneumatic cylinder as a tool that we can use and creating 3D model, out of 3D model, that it grips all the generic clamps in the same time, with somehow creating a feeder that deliver all the generic clamps in the same time. So we don't use the whole time for inserting one by one as it's used in the manual workstation. So here the pneumatic is moving forward and backward, and inside here we can see that there's holes that we insert magnets inside. So this housing, outer housing here, is preventing the magnets to stick to the metal clamps. So it basically goes in and out, and with this we release now in this position, and if it's forward inside, then it's gripping. So here the other tool that we said before for the CDMA clamps, that it's also based on the same concept, but it will be one by one. We could possibly do this with further research, that we can insert the metal clamps one by one and leave one terminal between them. So this is another option, but this is for further more research after. So here it's one magnet that goes inside and outside this hole here, and it's basically prevent the housing, outer housing is preventing these magnets to stick to the metal clamps, but it's inserted one by one. So here is the tool that we also create for the PCBA and the plastic base, and it was really hard to find a way that we can bring the PCBA and the plastic base in the same time with one tool. So here we have just two pneumatic cylinders and the housing, and this is just for the robot to be gripped with. So here basically we have the plastic base are similar from both the CDMA and the generic. But just the only difference is the downward part where there is the terminals in. So the terminals is the only difference here. So basically for the plastic base, we have first insert these two inside the plastic base, and then the pneumatic cylinder pushed in this direction so it can grip the plastic base. So in the other direction, we did it in this forward, the upper part here, we see that there is no components, and the downward part where there is no also components, so we don't affect the components inside the PCBA. With these parts, the first that we insert this downward part inside the PCBA from the downward part, and then we secondly push the pneumatic cylinder to the PCBA, so it's gripping the PCBA from the other direction. So for the L-shaped plastic part, this is the L-shaped plastic part as you see. So it has L shape, and based on this we use the parallel gripper. We pick the parallel gripper for gripping the L-shaped plastic part, and with this housing we are making sure that it is inserted on the right location on the PCBA. We took the idea of the pneumatic cabinets or pneumatic drawers from Iskra Emiko, also that they have some already implemented project that it is having some blisters inside this black here, and this has inside the plastic base, but this is just for a different type of meter. So it's already implementing what I'm talking about, what you will see after. So basically now this is the cabinets or the pneumatic drawers that I created using SolidWorks for Iskra Emiko specifically, that has the plastic base, and inside here that it has the PCBA. So basically from the back here you can feel the blisters, with the workers can feel the blisters on the back here, and also the plastic base. So here the last customized, this is the feeder for the L-shaped plastic part. So at the end here it delivers moves around and delivers the L-shaped plastic part to the robot. Then we have here another customized also for the vibrator bow that it delivers the CDMA clamps, and the robot comes at the end here, pick it one by one after changing the tool flows. Here is this tool was taking longer time to think about because it is not easy to fill all of them one by one. Since here we use the piston to fill with the vibratory bow, the one by one, the generic clamps. And then here we have the overview for all the how it is the robot cell. So here we have the tool changer. So this is the tools, all the tools in. And then here we have the metal holder, the meter holder. This holds the PCBA for the robot to whether putting the CDMA clamps or the plastic base which is in front of you here. So this is the push pallets and the robot is in front of it. So here we can see the overview for the fence and everything around. This is how we design it. So this is just a top view that you can see where is everything. This here that it is for the generic clamps, and this here is for CDMA, and this is for PCBA and for the both types of meter. And you can see now the video how we done the simulation using the. So here is basically the HMI that we use, and this is used by TIA Portal, and we connect both softwares together, the TIA Portal and the Robot Studio together. So now it is picking up the meter, the plastic base, and it's, you see here that there's also it's filling one by one the generic clamps, and then it's changing the tool to pick all the generic clamps and insert it inside the base here. So this is one thing, and then change the tool to pick up the L-shaped plastic part and insert it in the PCBA. So similar somehow to what the woman was doing manually. So we pick up the PCBA with all the components when there is inside the generic clamps and putting it inside. This was done virtually and physically on the robot down here, and with the 3D printing these tools. So this is this. So I can show you now the other video that it is for the generic. I didn't put it in the presentation because it's heavier. So okay. So basically now this is down in the lab, and here this is act as the wash conveyor, and now we have the pneumatic cylinder in just one side that grips the plastic base and insert it in the wash conveyor pads. So of course this is very hard to implement without stability, but it is somehow showing the idea of implementing this project in real, how it could be done. So here it's placed inside the push pallet after. Then it picks up the PCBA from the blister and basically inserted inside the holder. This is the holder. This specific step needs a lot of precision to be done with the distances and everything. So now as you see that it's inserted inside the holes with no problem. Now we can see how it is done for to do the L-shaped plastic part from the feeder. This is act like a feeder here, and we insert it in the PCBA. So this ensures the stability of putting this in the right location, the plastic base. Then here we have this is acting like a feeder, and then we pick it up and put it inside the cover, plastic base cover. And you see it's putting it inside the base. Then we pick up the PCBA from the holder and insert it inside the plastic base, where there will be generic clamps here inside. So the same as the woman was doing in Klein also, and put it inside the So this is done much slower here because it's just a trial, and we're just testing the concept or the idea that we wanted to prove. So now we'll release the meter. And it's going out. And you see the holes are inside with no problem, with also the L-shaped plastic part here. Okay? So basically, here you can see the L-shaped plastic part inside and the application, and everything is okay. So basically, this is the actual video. I can continue. CDMA. So basically now we are doing the other type meter, the CDMA. So here with the HMI we select that we wanted to, the worker will select that we want to do the assembly for the other type of meter. So basically we pick from the different drawer and put it inside the wash pallet. So basically everything is the same except for the terminals. So here it picks the PCBA and put inside the holder, and also fix the clamps, but one by one, as you see, inserted inside. This needs a lot of precision from the robot to do this because the space between the terminals are very tight. So basically, we here inserting it one by one, and as we said, in the future, if there is a room for improving this project, would be this. Because there will be, we can do it like one by all together, but we leave one in the middle that it's not all in the same time, but half of them will be in the same time. So this is it for this here, and changing the tool and putting now the L-shaped plastic part on the PCBA, and then changing the tool for gripping the PCBA and putting it inside the base. And also here it's putting it vertically, and the scan already was done, and that's it. So we can check also this how it is done in the video. For the other type, it's basically the same thing. The only difference. So it's basically the same thing. The only difference is the metal clamps. The clamps are here basically picked differently and placed differently. So here it is. This is the metal clamps here. So we will show how it is. So basically picking it up from the feeder and insert it inside the course, this takes long time to produce this tool to be able to grip and release the clamps inside. So as you see also here, I just show that it can be possibly put two together in the same time. Here then we can see that it's after placing all the metal clamps, we can take the meter with all the metal clamps and the L-shaped plastic part and put it inside the plastic base. But the only difference is that here we don't need to incline our motion to insert it inside the base, but just vertically insert it inside, which is easier than the other motion, of course. You see here the whole inside. And release it here, and you can see that the metal, the plastic L-shaped part is on location, and all the PCBA is inside. So this is basically it for this. And our conclusion of this is, so basically after showing this, we have done the increase in the speed of the project, 16%, which represent 92 meters per shift more in the generic meter, which represents 10 seconds faster than the actual with the manual workstation, and 51 seconds per meter to ID assembly. The other one, as we saw previously, it was 61 seconds from the manual workstation. For the CDMA, we increased the speed by 7%. This would be improved, of course, since we said that we can implement the insertion 4 by 4, not all together. So 26 meters per shift more than the actual workstation that is running right now, and this represents 84 seconds, which is in the manual workstation is 91 seconds. So then we also achieved 71% of the whole line to be automated, and also optimized layout with one robot. So usually in this industry we have one robot replace one worker, but now we have done to replace 2 workers by one robot, and this is because the bottleneck in the whole line is not in this part. The bottleneck in this line is in the middle, where there is another task is done. So now we achieve this 71% with one robot, and overcome all the challenges and things that was hard to facing our automation, and we've done this testing virtually and physically by, as we saw in the previous. That's it. Thank you.
Thank you very much. Very nice presentation. Very good work. And now we come to the section when we ask you a few questions. So we will ask Mentor, Professor Alex, say first questions.
Thank you very much for having the chance to ask a question. Firstly, I would like to congratulate on very nice program, and I also think that the presentation is very interesting and very structured. Now, let's go to the questions. So, maybe the first question is, how many robots are in your company this kind?
In this line, or in general in the whole production?
The whole production and on this line.
In this line, there is another 2 robots in this line, because it's a high run and they need this very important for them, this 3 phase AM 550, and they're producing from this so much, but in the whole production around 5 robots maybe.
5 robots?
Yeah.
Okay. I saw in your videos simulation also in the laboratory experiment
done completely on the line. Of course, money-wise and a company that can implement this. So basically, if you work with Discover robot or Coca robot or any other different robot, it has the same concept of the simulation. So basically, everything can be done in the simulation. But we pick one specific company that it has open, that we can use here in the faculty, the simulation, because of the license and because Dr. Timmy was also working with this. So we picked this specifically because of it, but I can work also in Scala software doing this. But due to the license thing, I didn't have the chance to work with it.
What are the other robots in company which
Discover and Cook and one ABB. Now I think they implement also for PCBA another robot. I think it's also from Discover.
Okay. Okay, now let's go to this application. First of all, your review is that in this robotic assembly, you deal actually with very sensitive components, right?
Yes.
These are very sensitive components, and the assembly is rather complex. Do you think that you might need a real application, also force control for assembly?
Force control?
Force control, when you put two components together,
That we
do
need
you think that you will need also control force during the assembly, or
sensing the force of this is also could be possibly done, but we have done it with no force control, and if we implemented even the force control, that might be also a thing, but also this depends on the company who produces who will take care of this project and implementing this project. So there is a lot of sensors that can be done, but just for the idea of the concept that we can automate this, because a lot of companies before this decided not to deal with this process because of the complexity of the project. So basically, with me, just one person in the university, with 3D printing tools that doesn't cost much at all, we prove the concept that it can be done for any company that can implement. But of course, if I have the chance to implement this project by myself, of course, for sure that I will implement force. Of course, that would be much easier and make it the whole process more smooth. And also, the most important thing here, the dimensions. So where it will pick it from, where it will place it in, this needs very precision. And the limitation here is very realistic. So we are dealing with these things. So if we have
that's why I asked, because you need sensitive components, and you also need very high precision.
Yes.
And in such cases, maybe one could think about
this is for
application
sure.
of the force control in order to prevent
Yes.
breaking the components.
Yes, of course. This is for sure should be done if we are dealing with the control of this whole process professionally and done like this. But just for the idea and the concept to prove that it is possible to be doing this, and then the room for improvement can be done after the course.
Okay, in conclusions, you stated some improvement in cycle time in comparison with human work.
Yes.
Right? So, but these data are based on simulation only, right?
Based on simulation and based on the maximum speed that we can do for the actual robot. But we can't do actual simulation because we don't have the whole components with us. So we could do this, but with very, like, the meter should be here, not moving, not anything, and can be done here in such an environment in the faculty. But it is possibly to say that with this simulation, usually any company that implements a project, they do its simulation first. With, for example, in my case, the Discover project that was done before this was done simulation first, and then they saw that everything is okay. Then they implement the project. And then this is done first by the simulation, of course.
Okay. Perhaps you would like to have such improvements also in case if this project will be realized.
Yes, of course.
And now I wonder what are actually requirements of your company. So your company possibly put some demands on the improvements. Is this enough improvement for the company?
Well, the company accepted the project if it is done, basically. If the project is done with no problem, then it's okay. But usually this will deal with contracts. So if there is any problem, the other company could cover these expenses, for example. So basically, I can't by myself implement this project because of the contract that we need to do. And the second thing, they accepted the project as it is, of course, and they took it as something that we should offer for a company like Iskawa or a different company, that they can implement this project based on my concept. So basically, they will go to the concept, see what tools that I'm using, and there is always a room for improvement. For example, the gripping for the PCBA and the plastic base, those can be picked much easier if I have different tools. But because I wanted to show the concept virtually and physically, that's why I use this specific idea or this specific concept. But there is, of course, much easier thing that they can grip the base and the plastic, the PCB in the same time also with one tool. Or we can also, for example, having multiple tools in the robot. So we could just, without changing the tool with the tool holder, no, we can just basically have two different tools or three different tools in the same time. Then we don't need to change the tool, and this will save a lot of time also. There's a lot of room for improvement. As I said, also for the CDMA, there was insertion of the 1 by 1, but it's possible to improve this by 4 in the same time with the implant. But we always need a base to start with, and the company couldn't afford the time that they do the research for such a project, if you know. So it's basically need more than 1 year to implement such a project with high precision, as you mentioned, with a lot of forces, with the whole programming of the TIA in the TIA portal or whatever, Alan Bradley or other different PLC.
Okay, my final question is, so what is the expected return of investment time on this project?
Well, this project, I think it's 1 year for sure, because we eliminate 2 workers from the line. So basically, this could be even less than 1 year because there will be one robot that covers the whole thing. And the most expensive thing in this project usually is for example, the customized feeders. This also is a point, but basically 1 year can cover this because we used one and we eliminate 2 workers at the same time.
Okay, thank you. Thank you very much. Now I ask also Tim Carmen this question. Thank you for my invitation, nice work. Do you have any information if this automation will be implemented according to what you have done?
Yes. It will be implemented based on what my previous boss told me, Nix Gorenchik, who was also in this project with me. But currently, because there is a change of new boss that implements this, so I managed to contact the bigger manager to implement this project. And it could be possibly within these 3 years that we can publish this project. That's why also we need these 3 years of not publishing this project. So we could see it in near future, 2-3 years, because this thing needs a lot of funds. We need to see who's funding these projects and these things. But it's definitely possible to do.
if you were the company that implements this solution, how much would it cost? Do you have any idea how much would you charge the company
Well,
to implement this solution?
implementing this solution could be really a challenge because the customized vibratory balls, this is also really vary from the companies outside. Because usually the company who's producing the programming and the whole project deals with the specific companies outside. Because it's my work as a project manager there in Iskarinuko, I know how it is done, so basically they don't go basically with the whole project and implement it, but they have another clients that they can use from them their customized vibratory ball. But that's why I'm saying I can't estimate exactly how much it will be, but more maybe 100,000 or maybe 200 even more, because depends on, this is just a range, because the customized things you can give an estimation for it. But if there we have a standard things, then, and this also is not based on me, because they don't use like really a terminals that is standard and or the clamps that it's standard. So basically we are doing customized things because we don't have standard things.
So if the company decides to implement this solution, and if they find out then on the real examples, in the real testing, that they would need to change some shapes of these meters, how likely are we going to do that? Or
No. This now, using this solution, I didn't change anything with the model. So basically, it is as it is. This project is done based without any further changes in the PCBA or the plastic base. That's their target. So that was also a very big challenge for me, since they don't want to implement any changes, since the R&D also can't afford to produce right now a new model. They can just cover the problems with previous models and the software also that it has. So basically the outer thing is fixed, but the software and these things, they are more into it. But after more than 3 years, maybe they could change the shape of the meter. Because anytime you change anything, you will find another challenges with the new meter for anything. And they can't right now, if the customer or the clients that they used to one specific meter, then they change this right now. But if there is a competitors that using this similar or giving them high chance of using less costs and this, so then in that time they should start thinking differently. So implementing new differently.
That's the common problem of the companies.
Yeah, of course.
Okay, thank you very much.
Thank you.
Well answers, as
Yes,
always.
thank you, Timo. Maybe a question from the audience. No questions.
No questions.
Okay. I have maybe one quick question, which is very similar to what you were talking now. So, if the product changes, how easily will the robotic cell
Could be
be changed to is it hard to,
It depends on the changes, of course. It depends on what they will change. For example, the terminals, this could change the whole concept of that we created here with the pistol and filling it one by one with the customized variables. So this is also should be keen about this. But since these things, I have an idea that they will not change these things. The terminals, for example, or anything like that. So basically, these things are not for changing, and this is can be changed at the moment.
Okay. Good. Okay, thank you very much. So I think we covered all the questions. So we need a few minutes now to discuss
Yes.